All right, we are going to continue on with solving quadratics by factoring. So we are going to solve quadratics by factoring. And we are actually going to have some practice on page 108. So we're just going to continue this skill. We're just stepping it up just a little bit each time in order to continue on with factoring. So we are going to be looking at problems today that are not necessarily in trinomial form. We're going to have to do some changes to make them into trinomial form, or maybe it's just even going to be a binomial. We're still going to be factoring. Our next unit after this will be when we can't factor. What do we do? But today, we're still going to go into this whole, still looking at this term, this polynomial, this equation now, because it has that equal sign, and going through and factoring it that way. So we're just going to get some extra practice underneath our belt. So let's go to page 107. And here we go. So we're still factoring, right? Solve quadratics, equations by factoring. And we're just going to get some practice under our belt. So the important thing to remember, again, is that we need to make, or maybe it already is, the equation equal 0. And that's how we solve. So we're just going to do a lot of practice today with getting these equations to equal 0. And then once they equal 0, then we can begin our factoring process. The other thing that we need to be really aware of is to make sure the equation must be in standard form. And we're just going to do a whole bunch of practice problems just to get ourselves ready for this, to get our minds in this right place, and then we can do some homework. But our questions still lead the same way. Is the leading coefficient negative? If the answer is yes, you need to factor the negative out, meaning everything in the problem changes. So maybe we will be encountering some problems like that today. So you need to look to see, is that leading coefficient negative? If that leading coefficient is negative, you need to factor that negative out. The second thing you need to look for is there a GCF? If there is a GCF, you're going to factor out the GCF. Now the GCF could be a variable. It could be a number, or it could be both. It could be a number and a variable. And then once you have gone through those steps, step 1 is the leading coefficient negative. Factor that out. Change everything behind it. Is there a GCF? Factor that out. Then you're going to look for factors of A, C that have a sum of B, and you will factor by grouping, maybe, right? And again, these are all steps that you can skip one of the steps. You can go from step 1 to step 3, right? You can skip step 2, you can skip step 1 and just do step 2 and step 3, right? But you're not going to go out of order. You're still going to go 1, 2, 3. You can skip problems. You could say no to any of these questions. But you have to go in this particular order. And then once you've factored, if it's factorable, which is what we're doing today, so they're going to be factorable, you will solve each factor and get 2 ordered pairs. Now, sometimes what we might start discovering soon is that your ordered pairs might be the same ordered pairs. When you factor it, you might get the same ordered pair. You might get the same ordered pair twice because each factor has the same solution. But and then in that case, if the ordered pairs match, you only write it once. But you're going to still be getting these binomials that you're going to be solving for. So let's just get in there. If you had, let's just go with what we did the other day. X squared plus 2x equals 8. It's a quadratic, biggest exponent's 2. I need to make it equal 0, meaning my problem does not equal 0 right now. So I need to subtract 8 from both sides, leaving behind x squared plus 2x minus 8 equals 0. Now I'm going to look, is there a GCF? Looking at these 3 terms, note they do not have anything in common, so I can skip step 2. Step 3, factors of AC that have a sum of B. So 1 times negative 8, so factors of negative 8 that have a sum of positive 2. And those factors would be 4 times negative 2, make negative 8, but 4 plus negative 2 makes 2. So I'm going to replace 4x minus 2x minus 8 equals 0. I can replace that middle term with those 2 terms and factor by grouping. Or because my leading coefficient is 1, I know that it's x plus 4 and x minus 2 equals 0. You can replace these 2 terms with the middle term and factor by grouping. That's fine. We don't have to because my leading coefficient is 1. I can skip that step. This first problem, x equals negative 4. So my ordered pair is negative 4, 0. And in this factor, x equals positive 2, making my ordered pair 2, 0. You may see answers written like this. That just means these are not parentheses. These don't mean that these are ordered pairs. These are brackets, meaning that they're 2 separate answers. So the answers, the solutions to this quadratic are negative 4 and 2, but the ordered pair answers are negative 4, 0 and 2, 0, because my x values are what I'm solving for, and my y value, my answer, is 0. So what we've been working with, right? We've seen these problems. Let's do 10x squared minus 50x plus 100 equals 100. So this is, again, a quadratic, but my quadratic does not equal 0. I need to make it equal 0. So I'm going to subtract 100 from both sides. And I'm left with 10x squared minus 50 equals 0. Oh, that should be 50x. Sorry, I forgot my variable, 50x. Okay. Is there a leading negative coefficient? Nope. Move on. Is there a GCF? Yes, there is a GCF. My GCF is 10x. And if I factor that out, I'm left with x minus 5 equals 0. But now I don't have factors of a times c that have a sum of b, right? I don't have that. I can't factor by grouping because I have this binomial left behind once I took out my GCF. So now I'm going to solve each factor because I still have two factors. Here's factor 1. It's just a monomial. And here's factor 2. It's a binomial. So I'm going to solve each factor for 0. So 10x equals 0 and x minus 5 equals 0. These are my factors for this quadratic. So this one, x equals 10 divided by, or 0 divided by 10 is 0. And this one, x equals 5. So my ordered pairs are 0, 0, and 5, 0. I'm still factoring it. It just ended up not being a binomial times a binomial this time. It ended up being a monomial times a binomial. And if I have two factors, I can still solve both of those factors. They don't necessarily have to be binomials. So let's keep going. We're just continuing this practice on page 108. And again, we are just factoring. We're just going to go through and we're going to factor and get all of these steps in order. So let's go with, let's see. Sorry, I'm trying to come up with a problem. Let's go with 7x squared minus 2x plus 2 equals negative 6 plus 8x squared. So my quadratic does not equal 0. So I'm going to have to take these terms and combine them over here. I'm going to have to move my terms. So I'm going to add 6 to this side. And I'm going to subtract 8x squared over here. Combining my like terms, since I'm crossing the equal sign, I'm using inverse operations. I'm left with negative 1x squared minus 2x plus 8 equals 0. Make it equal 0. Done. Right? It's in standard form. Done. Is my leading coefficient negative? Yes. So I'm going to have to take that out. And it leaves behind x squared plus 2x minus 8. This looks familiar. Equals 0. Negative 8. Factors of negative 8 that have a sum of 2 is positive 4 and negative 2. So x plus 4 and x minus 2 equals 0. I have a negative 1 leading coefficient. It's not going to affect my answers. X equals negative 4. X equals positive 2. So my ordered pairs are negative 4, 0 and 2, 0. Again, we're going through these problems to try to figure out where there are leading negative coefficients, if there's a greatest common factor, if it ends up being a monomial and a binomial, we can still factor that. It doesn't have to necessarily be a binomial and a binomial. The big part about today is just we're going to be doing a lot of maybe manipulation with our problem. And so really taking our time and making sure that we're combining the correct terms, that if we're using inverse operations, we're not making a silly mistake, right? We're just trying to get this into standard form to see if we can factor it. Let's do another one that's similar to this. Let's do negative 8m squared. Still going to be x. Doesn't matter if it's a different letter variable. We're still working with independent and dependent variables. 4m minus 5. Okay, not in standard form, right? Doesn't equal 0. Not in standard form. Let's get it that way. Minus 4m minus 4m and plus 5 and plus 5. Negative 8m squared. If you don't like working with the variable m, you can change it to x. That's okay. Minus 31m minus 21. So let's just think through this problem. I've got a leading negative coefficient, so I'm going to take that out, which leaves behind 8m squared plus 31m plus 21 equals 0. Let's see, is there a GCF in this? So if I'm looking at 8, factors of 8 are 1 and 8 and 2 and 4. Factors of 31, it's prime, so there's nothing. And I'm done, right? There's no GCF. Now, if this would have been, 30, and this was 9, I could take out a GCF. I could take out a number, right? I could continue to take out another value to make these coefficients smaller and easier to deal with. So I have this guy right here. All right, so let's talk this through. I'm looking for factors of a times c. So 8 times 21, which is 168, that have a sum of 31. So let's see. Times like this where I don't know factors of 168, I'm going to Google. Right now I'm typing in factors of 168. And if you look, I'll bring my computer over here. Factors of 168, there we go. And the factors are lined up 1 to 168, 2 to 84, right? They're opposite of each other. So I'm looking at factors of 168 that have a sum of 31. And we have 4 plus 28 is, oh wait, I'm off one. It's 34. 168 divided by 7. 7 and 24. There we go. So I know that 7 times 24 is 168, but 7 plus 24 is 31. So I'm going to put 8m squared plus 7m plus 24m plus 21 equals 0. I replaced my middle term with my 2 factors of it. Split it in half. M leaves behind 8m plus 7. And over here, what these GCF is 3. 8m plus 7 equals 0. I have m plus 3 and 8m plus 7 equals 0. This one, m equals -3. And for this guy, 8m plus 7 equals 0. -7 minus 7, 8m equals -7. Divided by 8, divided by 8. I'm just going to leave it as m equals -7/8. I'm not putting the decimal. You can put the decimal if you want. Doesn't matter. So my answer is -3, 0 and -8, 0. So today we're really focusing on additional elements before we start factoring and solving, right? Do we need to move terms, combine terms, get them all together? Do we need to look to see, is that leading coefficient negative? Is there a GCF? Maybe there's a GCF that we need to bring out. Are there factors of A times C that have a sum of B, and then solving each one independently? Again, you can skip steps. You just can't go out of order. You always need to start with number 1, yes or no. Number 2, yes or no. Number 3, yes or no. Number 4, solve. Right? So again, down here, we had a no to number 1. We had a no to number 2. We went straight to 3 and then solved. On this example, we had a no to number 1, but we had a yes, there is a GCF, so we factored that out. We had a no to number 3 because there was no A times C, right? We ended up with a non-quadratic after we took out our GCF. And so we solved each factor. Right, so you're going through these steps. You're going to be diligent about it. You're going to have to show your work on a piece of paper when you do this. It's going to be really hard to do, you know, collecting these terms together and not making a mistake. Right, combining like terms. Anytime you have to move something across that equal sign, it changes its operation. Right, inverse operations to move it across the equal sign. We're still solving each factor. But these are the steps that you're going to need to ask yourself as you go through these.